Welcome to the Penn State Horticultural Research Farm. My name is Francesco Di Gioia. I'm Assistant Professor of Vegetable Crop Science in the Department of Plant Science at Penn State. Today I want to show you one of the projects we are working on here in the open field on tomatoes. This is a project funded by the Northeast SARE program from the USDA. It's a project in collaboration with another faculty in the Department of Agricultural and Biological Engineering at Penn State, Dr. Longhi, and we are working on automated sensor-based irrigation systems. And we are testing different technology, different type of sensors, and different tools that allow us to manage the irrigation and the fertigation more precisely and allow us to optimize the management of the irrigation and the fertilization to improve the yield and the quality of our produce, and at the same time minimize any impact on the environment, reducing the amount of water that we use for a crop and reducing the amount of nitrogen fertilizer that may be lost into the environment for tomato crops. So what you see here is a popular variety used by growers. Is a round beef tomato steak. So like big size, and is used like is a slicer, so it's used to produce slice that then will be used in sandwiches or different things. We are 40% of the crop cycle, and since we planted them, we installed different soil moisture sensors. We have volumetric water content sensors and water potential sensors from different companies, and those sensors are connected to some data loggers, like you will see here. We have two different kinds. This is one that is more like commercial and has like 6 sensors connected to it, and that one is another one that we are developing with like a technology that is like more cost efficient and that allows us to do the automation of the irrigation. So we have sensors installed in different portion of the fields. So here's behind me is one of the sensors that you can see here, just the stake, and we have for each stake we have a sensors like that is at 6 and 12 inches deep in the soil, so that we take what is in the root zone and below the root zone. And that allows us to identify when we should start the irrigation and then when we should stop, to avoid that the water goes far deeper into the soil. And so these sensors are connected to those data loggers. Those data loggers use a technology that is called LoRaWAN. We have a router that is in one of our buildings. Like you could go up to like several miles distance, and they will communicate with via radio, and then the router sends that signal to a cloud service, and from the cloud service we are able to see what is happening in the field, and if we want to irrigate, just click the button and automate, like start the irrigation or stop the irrigation. What we are doing in terms of comparison is to basically manage the irrigation based on the evapotranspiration. So we have a weather station that is giving us all the data, the weather data, and based on which we estimate the evapotranspiration. And the evapotranspiration is basically how much water we are losing every day. We accumulate that up, we multiply with a crop coefficient, and then we know that we need to apply this much gallons of water per acre. Then we have 2 other treatments where we are managing the irrigation based on the sensors. It will start the irrigation where the soil is drier. So we are trying to see if we want to save more water. Is that possible, and will that impact the yield and the quality of the fruit? What you see here is our irrigation manifold, our irrigation table. Each line is a treatment. So we have treatment 1, 2, 3, and 4. And what you have here is like we have a main line where the water is coming from. It's our water source with a filter and all that. And then when we get here, this is what we call electro valve. So this is what is allowing us to open and close the water automatically. And then this is a pressure sensors right after the valve. And it allows us, when we are far away, like not in the field, it allows us to actually see if the pressure, when the water is on, the pressure should go up. This is a very simple system that growers use to inject fertilizer. So normally we'll have a bucket under here with the fertilizer, and this will suck up the nutrient solution and it will go into the line, into each plot, each treatment. So I'm just opening the system from here. I will put the number that allows to open all the valves, and then I say update, and in a minute the system should open. You will hear the sound of the water running, and you will see that the meter starts spinning. What we are doing different is that we are trying to develop something that is not commercially available and that is like lower cost, so that it will be used potentially more even by smallholder farmers, and that's our target here in Pennsylvania, because we have a lot of smallholder farmers. And then the other thing that we are doing different is we are actually measuring. You see all those plants here because we are measuring the plant growth, we are measuring the yield. So like as we start harvesting, we will select 10 of those plants, and every other week, every couple of weeks, we are going to harvest the fruit as a grower will do. But we are measuring all that, and then the data allow us to tell the effect of the treatments on the yield and a little bit on the quality as well.